Hello and welcome to Captain Bob. Today I'm going to show you how you can make and configure the attitude indicator. Coming up.
Captain Bob, he's my best friend and he should be yours too.
For this build you will need two servo motors, an Arduino Mega 2560, some M3 metric hardware, and these 3D printed parts. Our first step is going to be to put these servo motors where they belong. One goes inside of this 3D printed part, and the axis of rotation is left. So now it will look like this. The other servo will go onto this part, and the axis of rotation will be in the middle. Back to this part, you're going to take the servo horn off of the roll axis and place it in here. You can use super glue or find small screws and utilize those. Mine looks like this, and I screwed in a screw on the third screw from the center. Now I'm screwing it on from the inside. You can print out the picture of the attitude indicator here in the files, and then make sure that the middle is where the servo horn is at its central position, so it's a straight line basically. You can then clip it on here, and then this just clips into place. On the other end there is a space for a screw, so I'm using a 14mm M3 metric screw. I'm going to put a washer in the middle just to minimize the rubbing and scraping and to make it hopefully more smooth. This is too short, so I'm going to use a 20mm one. Now I'm going to screw the bolt on, and this is going to act more as an end cap than to tighten it. You want this to be very loose so it's nice and fluid, but you also want it to give structure. Now you'll see we have our two axes. To tell exactly how much bank you have, you can put this cover over and then screw it on with two M3 10mm screws. Now it looks even better and more convincing. This is fantastic, but it's not attached to anything, so now we're going to put the support pieces on. I'm using some 14mm M3 screws. Now that we screwed the support structures on, we can screw on the bezel. To wire the servos, the brown wire goes to ground, the red wire goes to positive, plus 5 volts, and then the orange wire goes to your pin on the Arduino. I'm using pins 3 and 4. Now we can go into MobiFlight. It is an open source program that allows you to interface electronical components with a flight simulator. So we're going to go to Extras, Settings, MobiFlight Modules, click on your Arduino, add device, and we are going to add two servos. I'm going to use pins 3 and pin 4. Servo 3 goes to the pitch, and servo on the pin 4 goes to bank. Now we can upload this to the Arduino and make our first output. So this is going to be the pitch, and the second one's going to be bank. We can see if there are any offsets, and if not, we'll have to find our own. There is the offsets position, attitude, pitch, and position, attitude, bank. You can use either of these But for the instrument, you want it to be what the instrument reads, not what the aircraft is actually at. So you can use attitude indicator pitch. I found it in the Project Magenta offset list. Just Control F and then pitch. It's the 11th result. And then copy the offset of 0 Foxtrot 70. And then the size in bytes is 8. So now we can go over to display, use the MobiFlight module with the servo, and we're using the pitch servo. The maximum rotation should be around 50-ish, but we're going to start at 10 to make sure that the position is right. So I already set my 0 position to the top of the pitch instrument, but you will make sure to do that in the construction. So now we can play around with the maximum rotation and make sure it goes all the way up to all the way down, but not too much. Value of 39 is too much. Value of 28 should be good. And yes, so I found that a value of 28 works about the best. Now you can go to your bank tab. Let's make bank. We're going to do the same thing. I just searched up attitude indicator bank, and I found a value of 2 Foxtrot 78. So I can just copy that into here, and the size in bytes is 8. Then go over to display and do the same thing. Pitch. But with the bank servo. We'll start with a low value just to make sure everything is smooth. So a value of about 15 will work. Okay, so you'll see that it does in fact move. You can see that it now moves. Quite a bit, actually. Look at him go. One of these days I should have an attitude indicator race. I made my servo have the centered at the 0 position, which works well if it was a stepper motor, but it's a servo that goes this way. So I need to set the 0 position at 90 degrees clockwise. It should look a little bit like this. Now if you press test, you will see that everything is working accordingly. There are a few more steps we need to take to get this to work fluidly and correctly, but now let's go into the simulator to know which steps we need to take. So right here I am in the simulator, and I'm going to press run. See what happens. I can explain. Okay, so it appears we forgot to set the minimums and maximums. So, for the bank servo, I'm going to go to the transformation and use a transformation of $ plus 90. This will get it from the side position to the up position. Then on display, I'm going to use the minimum value of 0 and the maximum value of 180. This is because there are 180 degrees on the servo, and the degrees of roll should match. As you can see, this now put it into the 0 position. This is because it's in the middle, and it now should be reading accurate, as long as I didn't mess something up. So let's go on to the pitch servo. There are about 70 degrees of pitch on this attitude indicator. We'll figure it out later. So I'm going to have the maximum value at 70. I'm going to add a transformation that is $ plus 35. This will get all of the negative values into a value between 0 and 70. So let's see now. And it appears to work. The transformations were pretty simple, just $ plus 35, to get it into the positive zone, and then $sign plus 90. Now let's fly to see if these are in fact correct. So now the attitude indicator is acting correctly. Of course it's not acting at all, so I'm not sure. Let's get started. Remember, aviate, navigate, participate. Ready? Take off. Okay. Due to the way the instrument was built, the pitch axis needs to be reversed. So you can go into interpolations. Okay. So you can go into the compare tab, apply interpolation settings, and then just go 0, 70, and then 70, 0. Now we'll see if it fixed it. And it did, which I already knew, because it's just a cheat code, pretty much. As long as the attitude indicator does not run away, it should be fairly accurate. Come back! Now the attitude indicator is working fairly well. Of course it's not perfect, but that doesn't matter, because it is close enough. If you need more help with this, you can look at how to do a servo, how to install MobiFlight, and if you're interested in other videos like this, you can look at my instrument playlist, which has all of the instruments I've made so far on the simulator, and all of the instruments that I will make in the future. Just like my attitude indicator, I'm gonna head out. I hope you have a fantabulous rest of your day. I'll see you in the next video, and have a good one.